Welcome to Mathematics Lecture series. We start another series, Applied Calculus. Here is lecture number one. Calculus relies on understanding the real number system. Here in calculus, we consider the function from real to real. What is real numbers on the real line correspond to a point on a line with each point representing a unique real number. There are inequalities greater than, equal, less than equal are utilized to compare real numbers. Combining two inequality can express interval subsets of the real number containing at least two distinct real numbers. This is open interval AB. Here AB are exclude just here we in this set in this interval all real number between AB are includes. This is closed interval AB. Here AB include and all real numbers between AB all also include. Here half open half closed interval. This is half open and that one half closed interval. Here 2 is in exclude, 5 is include. Here 2 is include, 5 is exclude. So these two intervals are half open, or we can say half closed interval. Positive infinity denotes infinitely far to right, excluding the symbol itself. Minus infinity signifies an interval extending infinitely far to left. Parentheses always used with infinite in mind to denote exclusion from the interest. They do not represent specific numbers. So here are some introduction of the real number systems and intervals. Some basic sets notations. Empty set always denote this phi or the set with no element. Then natural number are 1, 2, 3. Here is a whole number. If we add 0 in natural number, 0, 1, 2, 3. Here integers, negatives, 0 and positives. What are the rational numbers? The fractions of two integers is called rational numbers, means p over q. Here pq belongs to z and q must be not equal to 0. What are the real numbers explained in the next section? A non-zero real number we denote by r that across some intervals. Interval close in 2 6 means 2 is also include, 6 is also include, and all real numbers between 2 and 6 are in fact these real numbers are infinitely many. There are 2 6 open intervals, 2 is exclude, 6 and between all real numbers belongs to this set. Here half closed or half open interval 2 6. So 2 is include, 6 is not included, but from 2 to 6 all real numbers belongs to this set. Here 2 6 closed interval, so 6 is included, from 2 to 6 all real number also belongs to this set. So absolute value, the absolute of a real number x denoted by mod x is defined by this formula. Mod x, if it is x, then x greater than equal to 0. Mod x also is equal to minus x whenever x less than 0. Means if you have x is negative, then mod x is minus x. Here see mod 3 is equal to 0, mod is 0. Minus 5, so multiply minus 5 with 5, so we have positive 5. Here are some properties or remarks. Mod x always greater than equal to 0 means positive for every real number x. Mod x is equal to 0, then x is equal. There are two another ways to define the modulus of real number x. They are mod x is equal to square root x square. Also we can and defined in this way. And second mod x is maximum of from minus x to x. So here minus 4 mod we can also find by this for minus 4 square square 16 is equal minus 4. So maximum of minus minus 4 minus, so minus into minus plus 4. So what is the maximum? Plus 4. Geometrically, modulus or absolute represents the distance from the origin to x on the real line. More generally, mod x minus distance between, it represents distance between x and y. Here are some graph, and this function represent blue line y is equal to mod x, and that line dots with mod which represent y mod x minus 3, and that line represents 2 mod x minus 3, and that here 2 mod x minus 3 plus 4. So in detail we study the graph of the function and more about the function in next lecture. So from here in introduction lecture we define absolute value, real number system, and some important notation about the